blindly, like I mean to say, hit for comment for better reach CFBR in chat, right? So that this will probably reach out to few more peoples. Just go to this LinkedIn post, just hit comment for better reach, nothing else. And if you're done, just put done in chat. If you're done, just done in chat. Maybe there are a lot of friend requests, so I couldn't probably accept it. We'll accept it later, but like if you're done, just put done in chat. Thank you so much, Firosh. What I'm just looking at is just a comment for better reach, nothing else. Only one comment. No, this is not like what I have expected. I have expected more. Yep, there are three comments. Thank you, Firosh. Thank you so much, Mohammed. Shall I get few more? Please let's have a target of like means to say have a target of 25. If we reach like 25, then probably like means we will start our session. Thank you so much, Piyush. Thank you so much, Ratnavel, our regular Maharaja Kamachi from Oman. Thank you so much, Maharaja. Thank you so much, Ranjani. Still on 7. 11. Just put comment for better reach. If it hits 25, we will start. And the advantage is like I also know the people's those who are actively participating and probably actively there in this comments. Yes. Thirteen more comments and let's get started. Good evening, all. Thank you so much for joining on time. In fact, in time for mastering the ETAP class. So, what we are going to talk today is there in that LinkedIn post. We are going to talk a little bit of power system, little bit of power system studies, little bit of ETAP, and little bit of what ETAP can, and then like I mean, so say some real time case studies, right? That's pretty much like going to what we are going to talk about. So let's start with a simple question. Can you just quickly put up like when you say your background? When I say your background, whether you are into engineering, whether you are into operation maintenance, whether you are into testing and commissioning, whether you are into academics or you are into student, like can you just like put up like I mean to say your background so that like means I can align this session in a better way. And probably like if you add experience as well, that would be like means to say more useful for me. So what I'm expecting, say example, saying like design 5 plus years, operation and maintenance 10 plus years. So that probably like gives me an interesting idea, right? Firoz supervision consultant, Sony engineering EPC solar domain, Najib operation maintenance, Pius engineering 3700. Please rename yourself so that I can read your lovely name. Engineering, Muhammad operation maintenance, Aranganathan BTech electrical. I'm assuming it is a student. Vishnu operation maintenance, Najib fresher, right? Mahesh Dasari operation and maintenance, Colin engineering, Nateem maintenance, Subha triple E student. Thank you so much. Like I mean, so see, we appreciate the people those who are joining probably from the college campus. You are well ahead of others. right? When I have studied my BE electrical engineering, I am not aware, like, I mean, so say, what is the software can do. And I amazing. QA, quality assurance and quality control. Thank you, Justin, with the 10 plus year experience. Madam, TSO, transmission system operator. Thank you so much. iPhone, please rename yourself. TNC, thank you so much. Himan's operation maintenance, project 3 plus 7 years. PMC, project management consultant, 15 years. Operation maintenance, faculty member, 15 plus years of experience. BE Triple Scholar, student, TNC, 15 plus years experience. PSA, 1 year engineer experience, like TNC, operation maintenance, electrical engineer, Chimobi engineering. Okay. I'm understanding the first one is your name. Yeah. Thank you so much. Uh, design and engineering, super project engineer. Yep. I guess like the chats are probably flying. Thank you so much. Like I couldn't read all, but like when say I have understood at least the average like a feedback of like means to say who is my audience, and I love that energy, right? One thing is always our promise. Like I mean to say, we believe the biggest gift which you can give it to others in your life is the time. I strongly believe in it. The biggest gift which you can give it to the others in your life is the time. Thank you so much for joining with us on Sunday, 7 p.m. India time. That could be a different time, probably because people have joined from different time frame. On a holiday, you could have done quite a lot of things with your family. And thank you so much for trusting us and joining with us. If you're a regular joiner, just put R in chat. If you're a regular joiner, just put R in chat. If you're joining first time, just put FT, first time in chat. If you remember, like you're joining second time, third time, fourth time, you just put number of the time probably in the chat so that like I know, like means to say, right. Yeah, Ratnavil, regular. Kalimuthu, first time, thank you so much. Yokesh, first time, thank you so much. Madam, first time, thank you so much. Javit Akhtar, first time, thank you so much. Achilles, first time. Maharaja, second time. Narayana, second time. Prashant, second time. First time, second. Cool. That probably gives like a mixed thing. So thank you so much. Like I mean to say, though it's a thank you so much for all, but like means to say, I always give a special thanks for the peoples those who are joining first time, for the fact that like means to say you do not know who is Selvakumar, you do not know what Power Projects is doing. Despite of that, on a Sunday, probably you have decided to spend time with us, and it is my assurance. Next 75 minutes, it is assured that like you will go with some value than like what you have learned, or at least you will get an idea, like means where you can learn further at free of cost, right? Of course, at the end we will sell the course. No, don't doubt about that. At the end, we will sell the course. But that doesn't mean like our objective is to sell the course. The free webinar, 52 free webinars, what we do, 52 weekends. Of course, we are selling at the end. I'm not denying it. At the end, the objective is not to sell the course alone. At the end of the day, objective is to make the electrical engineering world better than like means to say what is today. That's probably pretty much our objective. So I could see 150 plus audience. And when I have probably posted, there are about only 50 audience. So I'm just probably requesting, there are quite a lot of first comers. So ensure that like means you are going and probably hitting comment for better reach button. So that probably helps to reach more peoples, right? So I have just posted about 15 minutes back. The post is reaching 284 peoples. I expect this post to reach more peoples. And if you have done, that's great. Ensure that you are connecting with me on LinkedIn also. Right. There are quite a lot of friend requests which I will accept it after this session. But ensure that like you are connecting with me in LinkedIn as well. If you ask me a question like why you should connect with me in LinkedIn, the answer is here. If you see my LinkedIn posts, right? This is of course like we are inviting for a free webinar to add a value further, right? If you look at the other one, this is on relay configuration. This is on like whether your transformer is 100% protected. Can you use 50 hertz transformer in a 60 hertz system? How to size the cable? Means to say, of course, this is another detail engineering course where we are promoting the course, but like still that makes some sense. At least like you go through the topics as an engineer, what you have to go through. How fast is too fast when protecting the transformer? When we are detecting the fault in 20 milliseconds and giving a trip command to the circuit breaker, if it isolates in another 40 milliseconds, is it good enough? Right? So why distribution transformers are star delta? This is like 1 week post like which we have posted, and probably like you can understand like means to say how many peoples this posts are reaching. It's reaching like 70,000 peoples, 5,000 peoples, 9,600 peoples, 65,000 peoples, 48,000 peoples, etc. And we strongly believe in one of the marketing, like means to say blindly add a value, like means to say close your eyes, keep adding value to the peoples. That is called marketing in our language. Whether we are doing a marketing, answer is yes, we are doing a marketing by means of adding a value. In case if you are not following me, ensure that you are going to this post, hitting comment for better reach, and ensure that you get connected with me. Even if you're not purchasing any course, still we love you to follow me as well as the power projects, so that like you will add a value and attend all the free webinars. I know there are people those who are coming only for the free webinar every Sunday. Still I love them because at least they are spending 1 hour 30 minutes every week for their learnings. A slow steady progress definitely will take you to the next level. I have started reading standards, and I have started spending at least 2 hours a day when I have graduated in 2006. Today, I will be able to talk about almost all the equipments, their standards, the reason behind why the standard has been given, and how to implement that in, like, means to say, real world, how to use the software for that applications, etc. I know because since 2006 up to 2015, 9 years, I have spent at least 2 hours on a daily basis on electrical equipment standards. So, I mean, to say, ask yourself when you're working for 9 hours for your organization for the salary money, how many hours you are investing on yourself? I'm not saying you have to invest in our course. No, even self learning by probably going through the standards or probably our blogs or our YouTube channels or probably like wherever it is technical, put some consistent learning that will take you to the next level. If that is making sense, just type MS in chat and we will jump onto the technical. If it is making sense, just type MS making sense in chat and we will. All right. Cool. Let's get technically started. Let's talk about models and applications. And like I mean to say, just blindly asking a question, like I mean to say, what is your understanding on power system? So what we are going to talk about is power system. Then only like we can talk about models. We need to understand what is power systems, right? What is power system? What is power system analysis? What is power system simulation? Like let's say like power system analysis, like let's say power system simulation, power system simulation software, right? Power system studies, like means to say types. This is where this applications, etc., etc. Right? Then that's pretty much like what we are going to probably talk about. So what is power systems? What is power systems? Any answers? Yeah, probably like let's make this session interactive. Like I'm okay with if you have questions in between or probably like putting the answers, though it slightly divert the attention, but like I want to have like I mean to say lot of energy in the room because I believe our system is the most dynamic system in the world. Power system is the most dynamic system in the world. That's the only system in the world where the generation and consumption has to match each and every millisecond. I'm talking about my t-shirt. I'm talking about my phone. I'm talking about my water bottle. So all these things are manufactured on the time at which the manufacturer needs or manufacturer feels it's comfortable for him. And the consumers buy it when they need it. That means for any commodity or a product or a service, right? Like there is the time gap between actually it is produced and actually it is consumed. You take any product, even if I'm going to a hotel, if I'm ordering some food for me, still there is a gap, time gap that might be minutes, that might be seconds, but still there is a gap between the customer, probably customer consumes it, and then probably like means to say it's happening. I mean to say on like manufacturing. When they say manufacturing, it's with respect to the products, or probably like it is applicable for services as well. But only commodity or only service which the generation and consumption happen at the same moment is electrical energy. That makes the electrical system most dynamic system in the world. And we are talking about that most dynamic system. So we should have a lot of energy, right? If you understood electrical energy is the most dynamic system in the world, just write dynamic in the capital letter in the chat. Power system is the only system, or electrical energy is the only energy where the generation and consumption takes place at the same time. There is no other systems or equipments or anything which doesn't have that much dynamic. So power system is the most dynamic system in the world. Yeah. Thank you so much. I guess like now I have an energy. Right. So last week I was in a travel. I was a little bit tired. So that's the reason why like I'm just probably getting energized myself before jumping into. Good. Having said that, power system is the most dynamic system in the world. Let's ask. Let's ask another important question. How do I need to study this power system? What are the studies which I need to perform? I need to meet the generation and demand at the same time. That's one objective. I need to ensure that like means each and every moment the consumer needs something, I need to provide it. Say example, 7 o'clock I have started this webinar. I came, I have switched on the light, I have switched on the fan, I have switched on my laptop, I have switched on my camera. It's all consuming power. But I have not called the electricity operator or a dispatch center stating that I am going to switch on the light, which is going to consume power. So ensure that it is made available for me. I have not informed them. So power system becomes most dynamics from another perspective as well. That means the consumer never gives pre-intimation to the people, those who are managing the grid or those who are producing electrical energy. Power system, like means to say example, if I want a car, if I want a t-shirt, or if I want something mobile, like means I'm sometimes going and probably pre-ordering, which means like means to say I'm intimating like who is responsible for it, and I'm giving an enough time. But here I'm blindly going and switching on the light, right? When I switch on the light, I expect that light to glow. In order to meet that, somebody should have generated the electricity at the same moment. If that electricity has to be generated at the same moment, without any pre-intimation, I am not really the only consumer. There are infinite consumers from the households, domestics to probably like means to say industries and stuffs. So it is extremely difficult for the utility who is unaware how much load is going to happen in the next moment, though they use some forecasting techniques, etc., etc. But in ready-made, they do not have a data of what is the load which is going to be next second, next minute, next hour, next day. Of course, there are tools available. You will be able to forecast it, but that doesn't guarantee that that's probably the demand which is going to happen. Probably 1 degree ambient temperature change, 1 degree ambient temperature change makes the power consumption completely different. Probably a important some functions or an important day completely changes the power consumption pattern. So these are all something your load forecasting cannot do. Despite of it, despite of it, let me say the regulating body who is managing the generation and demand kept the generation and demand equal at each and every moment, despite of the loads are consistently and continuously changing. The biggest problem is unpredictable load, which is changing with respect to the time. If you have understood, like means to say, the first culprit or first uh, element which makes the power system dynamic means to say, just put number one in chat, which is unpredictable load. If you have understood unpredictable, just put one in chat. So that's the first culprit. Right. Let's come to the second culprit. Yep. Still, I want to have that energy. Like we have 200 plus people. At least I need like means 100 plus chats, right? We need to understand like I mean, so say the energy in the room, right? And when we are talking about most dynamic system in the world, we need to be having like I mean, so say high energy. All right. Coming back, uh, like I mean, so say we have talked about one culprit who is unpredictable load, who is keep changing without probably any pre-intimation. This is a second culprit. Like means if you look at 30 years back, means to say this problem is quite simple. The load is unpredictable. The load will be keep changing with respect to the time, but they have a controllable source like thermal, gas, hydro, etc. and rotating masses that stores the kinetic energy. So whenever there is a sudden change in load, the kinetic energy will be released and the frequency will change and probably like governor will act and probably bring back the frequency to 50 hertz. What I'm talking about is like 20 years, 30 years back. So which means 20 years, 30 years back, this problem is a little easy because load is the only thing which is uncontrollable. And when the load is changing, my kinetic energy available in the rotating machines of the gas turbine generators, steam turbine generators, hydro generators will be released to meet this immediately. And that will reflect as a change in frequency control. So that was like means quite straightforward. And like means to say, but lost lost couple of decades, we have a challenge. Like we are adding renewables, wind and solar, which is unpredictable as well, right? When sun shines, it will generate electricity. When the wind blows, it generates electricity. We cannot predict, like means to say, solar as well as the wind. So the second culprit, which adds a fuel to the fire in managing the most dynamics grid, is unpredictable sources. So if you have got the second culprit, just put two in chat. Put two in chat. Like one, we have understood it is unpredictable loads. Number two, we are talking about uncontrollable sources. Right. Beautiful. Love that energy. Right. Great. So when we have understood this, let's go back and probably talk about means to say, like means to say, uncontrollable loads, unpredictable sources. At the end of the day, quality and reliability is utmost important. Talk about an application like a data center, hospitals, a military, like army or navy. right? Like, I mean, so say you have like extreme critical loads which needs reliable quality power. So means was I'm adding a dimension of like what's the challenge as a power system engineer or electrical engineer we need to probably face, right? Uncontrollable, unpredictable load, uncontrollable, unpredictable renewable resources, and extremely critical loads which demands 100% reliability with the best power quality, right? Like I'm talking about data centers, hospitals, military, or army, probably some applications like that. It's probably the third dimension of power systems, or third dimension of power system dynamics. And like we have to talk about the fourth dynamics that is most important in everybody's life, that is money, right? I'm giving a quality power, I'm giving a reliable power. Shall I increase, like means also my electricity price by 10 times? Even if I increase by 5 percentage the electricity price, I know the people's those who vote for the opposite party just because like the electricity bill has increased by 5 percentage or 10 percentage. I'm not saying they are wrong, but I'm saying there is a fourth dynamics, which is the most important dynamics. Of course, you have to meet unpredictable loads. Of course, you have to manage uncontrollable sources. Of course, you need to maintain highest reliability, availability at the utmost power quality. The last but most important dynamics is at what cost or at affordable cost. That's probably like fourth dynamics, and that's all about power systems. If you have understood this four, you are great on power systems. I have not given a time for three and four. So if you have understood the third dynamics, which is availability, reliability, and the power quality, and the fourth dynamics which we have talked about is the economics or a cost. If you have understood one, two, three, four, just put three and four in chat. Like, just put three and four. Yes. And yeah, one, two, three, four. Thank you. Thank you so much. I love that energy, obviously. And let me tell a true story. Right. How many of you want a story? Just put story in chat. Let me tell a true story. Unpredictable loads, unpredictable sources, reliability, quality, economics. Thank you so much, Sony. But like, if you have said this to everyone, like everyone would have been loved it. Yeah. Else, like I will ask my team to probably copy and paste what you have probably put it as a note. Yeah. 2002, I have completed my schooling. I am joining BE Electrical Engineering in one of the engineering college. Like means first semester, like coming to say, there are multiple subjects. Like they are probably giving a syllabus book for the 8 semesters. Means to say, each semester consists of 6 theory, 2 labs, and final semester consists of a project. Like I mean, so totally like 48 theory, 16 labs, one projects. Like I mean to say, from an ordinary government school, local medium student, probably joining an engineering college, first graduate in a family who do not have electricity till his eighth standard. Like I mean, so say it's like mind blowing, and probably like means to say I have asked a simple question to the faculty who has distributed that syllabus book. Sir, the syllabus book is great. We have 8 semesters, 4 years, 48 subjects, 16 labs, one projects. How this will make me just school passed out student from local Tamil medium student, how it will make me an extraordinary electrical engineer. Right. Means what to say? I'm not really sure what happened after that. Like, I means to say, even my other friends, like, means to say, other class students, even the seniors, those who are coming for probably ragging, asking, who is Selvakumar? Who is Selvakumar? Who is Selvakumar? Who is Selvakumar? Like, I mean, I have not asked the wrong question. I have asked the right question. Like I thought like okay, like everybody is asking, like I also probably become like a superstar probably in like first day in the college itself. I'm a bit happy. But like I mean, so say when the results came, like end semester result came, then I have understood. Like I mean, so I have just passed in all like external exams, not in the internal exams. That's on the funny note. But means so say one thing which was probably very clear. My question is the right question. The question is the right time. Unfortunately, this invented to a wrong person. That's it. I haven't get the answer, but probably like means after spending 4 years, eight semesters, 48 theories, and 16 labs and one projects, like means to say when I have started applying this in power system studies on probably my job, then probably like means to say I have understood what is electrical engineering is all about. Electricity, neither natural nor induced. Electricity is not available naturally, just like means to say solar or wind. It's not naturally available. You cannot use it directly. Electricity cannot be used directly. Uh, Electricity can be used directly to kill a human beings. That's the only thing like application which I can see like direct electricity. But apart from that, like means I couldn't find any direct application of electricity. That means electricity has to be converted into a heat or light or rotational, mechanical, like whatever means some other form of energy. So then, like, means it's a simple question. Electricity is neither natural nor induced. So then I have asked, then why electrical energy? Electrical energy is a form of energy which is equipped with efficiency, economic, and enviro free. If you want to transmit the energy from one place to the other place efficiently, economically, and in an environmental friendly, electricity is the best form of energy. Means if you want to transmit uh, temperature from here to say example 50 meters, it is not that easy. Probably you might have seen centralized air conditioners in big malls, like means to say even for probably like means the cooling energy is what they are trying to probably distribute, like means that's insulation medium what they have, etc., it's like enormous and the losses are extremely high. That's the reason why like means they couldn't put up an air conditioner at some part of the country and distribute the air conditioners to every home, right? And probably like means to say if you probably trying to transmit something else that may not be economical, or some energy if you try to like send it from one place to another place that may not be environmental friendly. If you compare these three parameters, three key elements: efficiency, economy, and enviro friendly, electricity is the best form of energy. So like means to say I couldn't get the answer in my first semester from my faculty, but I have understood that probably after 4 years when I have joined my first company, when I have started doing a power system studies for the entire country level, I have understood electrical engineering is all about like nothing but a transportation is what we are doing. We are safely, economically, efficiently transmitting the energy. So we should be proud of we are the most dynamic system in the world who are efficiently, economically, enviro friendly transferring the energy. If you got this efficiency, economy, and enviro friendly, just put a triple E in the capital in the chat. Cool. Always. Yeah. E power 3. Thank you so much for a socket. Cool. Which took for me probably to realize that I took a lot of time. And what we are going to cover that today is exactly this: power system, generation, transmission, and distribution. If you want, you can add utilization as well. And probably like we have talked about why electrical. So means what to say, if you want to transfer the energy economically, efficiently, and enviro freely. That's pretty much why do you need electricity. Like means what is the characteristics of power system? If we talk about power system dynamics, right? So it is most dynamic in the world. Generation and consumption takes place at the same time, right? Power system is talking about generation, transmission, distribution, and utilization. Power system is the most dynamic system in the world. Generation and consumption takes place at the same time. So it is important to manage the generation and demand at the same time. And then probably like means why do we need electrical energy? Economically, efficiently, enviro friendly. If you want to transfer energy from one place to the other place, you need this. And why do we need a power system simulation? To do all this, obviously you need a power system simulation. Then what are power system simulations broadly classified as, right? What are the types of power system simulation which is broadly classified as? Broadly, it can be classified as steady state and dynamics. Steady state can be like means say further you can probably classify as like load flow study or a power flow study. Load flow study or a power flow study. Short circuit study. Many people think short circuit study is a dynamic, but actually short circuit study is a steady state analysis. Relay coordination, protection coordination, arc flash studies, harmonic analysis. These are all like steady state analysis. Dynamics further classified into electromechanical transient, electromagnetic transients. So power systems are majorly classified into steady state and dynamics. Steady state, like you have load flow analysis, power flow analysis, short circuit, relay coordination, arc flash, harmonics, etc. Dynamics, it is further classified into electromechanical transient and electromagnetic transients. Electromagnetic transients, you have like means to say motor starting or motor acceleration study and a transient stability. Electromagnetic transients further classified into temporary over voltage, slow front over voltage, fast front over voltage, very fast front over voltage, ferro resonance, transient recovery voltage. So I guess like this, I have made a beautiful mind meister and classified like why do we need to perform load flow, why do we need to perform short circuit, why do we need to perform relay coordination, arc flash, harmonic analysis, etc. All those who have commented for this post, ensure that you are reaching out to Manoj on 19th. Let's give him 2 days. So means to say 17 and 18, give him 2 days. In case if he is not sending this mind master, which I have made to probably simplify and talk about the applications and like softwares, reach out to Manoj. And Manoj, can you just put up your LinkedIn profile and contact so that like they will be reaching out to you in case if you have not sent. So all those who have made a comment, don't worry, you will get the like means to say detailed mind master which comprehensively covers in detail about this in your WhatsApp or in your email or in your LinkedIn itself. In order to do that, ensure that like you are connecting with Manoj, who has shared his detail uh, in the chat. So it's certificate, payment related queries, or probably the bonus and the gift, like what I have talked about. It's a mind master which consolidate all this, but he will share it only with the people those who have commented it. Like I am seeing there are 20 comments. Thank you so much for all 20. And ensure that like means you're connecting with Manoj and probably like means to say, like means to say, collect that mind master from him, right? All right. So like we have talked about power system, we have talked about power system dynamics, we have talked about why electrical, we have talked about power system studies. And like means to say, when we are talking about a power system studies, obviously this needs to be done in a simulation. Why simulation? Why simulation? Simple. You will not really be able to, you will not really be able to physically install, implement, and test something. Say, example, if I want to launch a rocket, shall I directly build a rocket and probably launch it? You can do, but if it fails, the cost of that mistake is extremely expensive. Same thing, you can build a power system without power system studies, power system simulation. The cost of failure is extremely expensive. So then why do we need a power system simulation? Probably like means to say while launching a rocket, you will check like right weather conditions, like what are the equipments which is needed, like where it has to land, what is the velocity, that these like you will study multiple parameters. Similar fashion in a power systems, the most dynamic system to work, like you need to probably do multiple simulations. That one of the multiple simulations which you need to do is like this, the studies which we have talking about, the studies which we are talking about. When we are talking about the studies, the simulation becomes inevitable and unavoidable. Power systems simulation is inevitable and unavoidable, which you need to do. You need to do this with an fact that like you improve the reliability, you improve the availability, you ensure that the highest power quality, minimum possible losses with an enhanced voltage profile, optimal equipment loadings. If there is a fault, only the faulty portion is isolated, etc. So far, if the session is useful, just put useful in chat. I have promised at the beginning of the session, right? Like I mean to say, it is my responsibility to add a value. If the session is useful so far, just put useful in chat. All right. Thank you so much for very useful. Great, amazing. Thank you so much. That's great, right? All right. Cool. Holding the chat for a while. And I know there are probably people who are putting in the uh, chat to get the, like I mean to say, the mind master, the summarization of the points probably for this link. So I'm sharing this link again. In case if you have not commented, ensure that like you're going back to this and ensure that you're commenting, and just not that, just keep comment for a better reach. That's good enough. But after that, ensure that you connect with me. But the gift will not come from me. The gift will come from Manoj. So ensure that like means so you are connecting with means or say uh, Manoj as well on LinkedIn. Right. If you're done, just put done in chat. So that like means to say we will go ahead further. If you're done, just put done in chat. Yeah. Cool. Let's go ahead. Let's go ahead. Right. Coming back, power system simulation softwares. There are multiple power system simulation softwares are available. not only the ETAP, what Manoj is going to share this MindMeister that will consist of all the power system simulation softwares in the market. Like just to name few softwares, ETAP, EC Power, SKM, Sime, Aspen, PSSE, DIgSILENT Power Factory, right? Like these are all few power system simulation softwares in the market. ETAP is not the only power system simulation software in the market. So if you are doing industrial power system studies, ETAP is an amazing choice. If you're talking about a grid level studies, like that means utility level, country level, state level, PSSE is good to go software. If you're talking about a DIgSILENT Power Factory, renewables, wind, solar, battery energy storage systems, microgrids, etc. Like means to say, I suggest you to use DIgSILENT Power Factory. So ETAP for industrial power systems, PSSE for grid level studies, DIgSILENT Power Factory for renewables. We are offering courses in all the simulation softwares. You can probably reach out to our team, right? Though probably like we are talking about ETAP, but we are offering not only like, I mean, so to say, the training in ETAP. We are basically a power system consulting organization serving 52 different countries, 52 different countries, performing this services and use this training as our marketing tool to get our customers for this power system consulting jobs. So training itself, our marketing for our consulting business. So we use all power system simulation softwares. And then probably like means to say, you need to know at least like there are few simulation softwares that which are there in the market. And just to give an idea, like you need to do PSCAD for electromagnetic transients. So at least like if you want to save yourself as a power system engineer, these are all like four softwares: ETAP, PSSE, DIgSILENT Power Factory, PSCAD. These are all the four softwares which ideally you should know if you want to save yourself a career in power system simulation. Where you will start with, like I mean to say, ETAP is obviously user friendly to start with, right? So for training related inquiries, ensure that like you reach out to Priya. Like Priya definitely will probably like means to say help you, right? That. So having said that, let's probably open the software ETAP. Like I'm just going back to this LinkedIn post. So means to say, so far what we have covered, we will talk about, right? So far what we have talked like about the models and applications. What are the models which we have talked about, like steady state dynamics and electromagnetic transients? Like we have talked about like different models, system modeling, data input, simulation case studies. We will start with an ETAP. If you're super excited for an ETAP, just put ETAP in chat. We will go to ETAP. If you're super excited for ETAP, right. Cool. So ETAP is not the only power system simulation software, as I told, is one among multiple power system simulation software. And like I have probably defined its application. If you are doing power system studies in industrial power system studies, then my choice is ETAP. So that means you are working for a data center, hospitals, commercial buildings, oil and gas, FPSO, process industry, steel, cement, tire. Like ETAP is a good tool to go for. If you're doing country level load flow studies, short circuit studies, stability, then choice is PSSE. If you're talking about wind, solar, battery energy storage systems, microgrids, DIgSILENT Power Factory. If you're doing an insulation coordination, lightning over voltage, switching over voltage, etc., then PSCAD is the tool to go for. Right. The notes you will get it when you have commented. So I will ask maybe the notes which I am just probably putting it to just to slow down myself. My energy is so high, like I will go a bit fast, and probably audience will not be able to go. That's the reason why, like I'm just probably making a notes here. But otherwise, like all these things are probably summarized in the main master, and that's the main master Manoj will share for the people who have commented on it. Right. But if you want, like if you feel this notes is valuable, like I mean to say, Manoj will attach this document also while he's sending it. So, but ensure that like you're connecting with Manoj. And like the software ETAP is up. Let's talk about like I mean to say what are the studies the software can do, ETAP can do load flow, which we have talked about. Like means to say, you can probably come back here and you can watch load flow, short circuit, arc flash, all steady state, motor acceleration, transient stability, harmonics again steady state analysis, transient stability, relay coordination, both overcurrent and earth fault, distance protections, DC load flow, DC or short circuit, DC arc flash, battery sizing, unbalanced load flow, time domain load flow, unbalanced short circuit, voltage stability, optimal power flow, reliability assessment, capacitor switching or optimal capacitor placement, and like I mean to say, switching optimizations, and like I mean to say, further contingencies, electrical traction applications, and like a real time. Like I mean to say, there are multiple applications the software can do. So that probably concludes or summarizes like what are the models and what are the applications, right? So what the software can do? Software can do all this, all this, all this, all this studies, right? If what ETAP can do, if that is clear, just put CC in chat. What ETAP can do, if that's clear, just put CC in chat. CC stands for crystal clear for our first timers for us, right? CC stands for crystal clear. So what ETAP can do is clear, just put CC, crystal clear in chat. Right. Obvious. I love that energy. Cool. Coming back. So like means to say, what are the equipments ETAP can have? ETAP has multiple equipments like bus, node, bus duct, busway, two-winding transformer, three-winding transformer, open delta transformer, voltage regulator, earthing transformer, cables, transmission lines, series reactors, grid or utility, generator, wind turbine generator, solar inverter, induction motor, synchronous motor, lumped load, motorized valve, static load, capacitor bank. So all these elements the software has. If you name any electrical equipments like this has, is it just that? No, it has further equipments like static work compensation, HVDC, like it has fuse, circuit breakers, it has CTs, VTs, relays, charger, UPS, variable frequency drives, rectifiers, all this equipments the software has. So one side, like we have talked about all the studies, and other side, like we have talking about all these equipments. So you cannot use ETAP if the element which you have to use is not available here. Only you have to pick the elements which are available and you can use these elements. But it covers almost all the electrical equipments in the power systems. If that is clear, just put CC in chat. If that is clear, just put one more CC. If it is clear, put one more CC in the chat. Cool, that's great. Yep. My water bottle is empty now, which means like I need to probably wind up before my energy drains. All right, cool. So going back, and let's talk about some real-time systems. Let's talk about some real-time systems. So what probably like a real-time system looks like and stuffs like that. So for that, like I will probably pick it up one of the course which is available in our case itself. Done. real-time case study using ETAP. I'm just probably say pick it up one of the course, right? I'll just show you what is this course is all about. Like it's one of the real-time projects which we have done for our participants. Like means what probably the participant will be able to see this. Like introduction to OLTC, power system studies, simulations, inference, nodes, single line diagram, etc., etc. Like all this informations, including slides, will be available. This is one of the case study. It is not probably the basic theory. It is one of the case study which we have done. So I will probably pick you up maybe another, case study, other case study, and then probably, just give me a second. I will probably open up another case study, and that will give you maybe a bit more insights. I will probably download the single line diagrams in detail from that. Yes, it is. Here we go. It's another interesting case study, load flow studies using ETAP real-time case study. So we have session one, modeling in ETAP, framing the cases, simulations, inference results, ETAP SLD, input Excel notes, ETAP simulation files, transmissions, like some Q&A. So let's look at means what is there in the ETAP SLD, and probably let's pick it up that project. What you will have, there is an ETAP SLD which you can probably download it. So ETAP SLD is the name of the file. It is here. So this is probably the single line diagram. This is a single line diagram. And as I told, ETAP is applicable for real time industrial projects. This is a typical example of an industry, steel industry. This is a steel industry, and the steel industry consists of rolling mill, electric arc furnace, ladle refining furnace, rolling mill, electric arc furnace, ladle refining furnace, and then probably these are all loads not only having a poor power factor but also consumes a current which is not sinusoidal. So obviously you need a filters, you need to. Sorry, I guess I got disconnected. If you're able to see me, hear me now, can you put loud and clear in chat? It is my internet disconnection. If you're able to see me, hear me, just can you put loud and clear?
Yeah,
I guess
yes,
my
right now it's clear.
yeah.
Yes,
Thank you, Praveen. Fine, fine. My internet got disconnected. Sorry for that. And probably coming back. This is a single line diagram. This is basically gets a power supply from the grid at 220 kV, and then probably means a transformer 110 kV, 110 kV line, and then probably a double circuit, bus bars, all the details which I have talked about. This is basically converted into this means say ETAP single line diagram. And this is SLD of the plant. So this industry needs what are the studies? Of course, you have a loads, of course, you have a generation, and you have perform load flow analysis to find out the voltage profile at all the buses, to find out the losses in each branch, to find out the total losses, to find out what's the power which you're importing from the grid, what's the power factor, what's the power factor correction which is needed, how to set the generator terminal voltage, etc. So, like, you will be performing load flow analysis. You will be performing a load flow analysis to do all those things. It is not a simple single step. Like, I mean, so say you need to perform load flow analysis. I will probably show you something in case uh, like what the load flow. Like, I have made some LinkedIn posts sometimes back. I will probably, like, I mean, so say put up this document in case if it is available in the LinkedIn post, because like LinkedIn is not really a good search engine algorithm, right? Like, I have tried it. Load flow objectives. That's probably like the post which I have done long back. Post posted by me. Steps to solve. Okay. Like, still, what's the post which I have expected? It is not coming. That's probably like LinkedIn algorithm. So why you have to follow me in LinkedIn is also like because I add like quite a lot of value which I couldn't myself trace it. Right. So you just find out that probably the this one means to say, but like I'm just quickly going for a load flow. Why do you need to perform load flow? To find out the voltage drop in each branch and voltage at all buses. You need to do, like, means to say, real and reactive power loss in each branch and total losses in the system. Why do you need to perform a load flow? I'm just giving in inputs. Voltage drop in each branch, voltage at all buses. Find out all this. Find out the real and reactive power loss in each branch and find out the total losses. To find out the equipment loading of each branch, or probably like sizing of equipments, or probably talking about like means to say continuous rating of equipments, to find out reactive power compensation which is needed, reactive power compensation studies which is needed, or probably like I mean to say this could be like means to say reactive power compensation in the sense like what's the capacitor rating which is needed, or what's the shunt reactor which is needed, right? What is the capacitor bank which is needed? What is the uh, like means to say reactor which is needed, or probably to find out like means to say what is the steady state stability limit, steady state stability, or to set the generator terminal voltage, to check whether like OLTC is required or not. If required, like means to say what's the OLTC range and the step. So why do we need to perform load flow? To find out the voltage drop in each branch, to find out the voltage at all buses, to find out real and reactive power loss in each branch, and find out the total losses, to find out the equipment loading and check the size of the equipments are okay or not, continuous rating of all the equipments, to find out what's the reactive power compensation or a capacitor bank or a shunt reactor which is needed, to check and ensure that the system is steady state stable or not, to identify what's the generator terminal voltage set point which we need to give, and also to check whether the transformer has OLTC is required or not. If needed, like what's the range and what's the step. These are all like very few reasons why do we need to perform load flow analysis. And probably the mind method which I have talked about will consist of all this informations. Still, if you feel like the notes which you feel it is adding a value, I will share you this as well. If that's clear and useful, like put one more useful in chat. One more useful in chat. right? How many of you are seeing a value, right? Like I have made a promise that like means next 75 minutes, uh, like I mean, so say, I told like means to say the time which you are spending, it's my responsibility to say that like means to say make the time which is meaningful, right? So how many of you are getting a values in the session? And the best value or the best marketing tool, according to me, is adding value to others. Yeah, the chat probably like sometimes it is disabled, probably to uh, ensure that like smooth flow of the class. That's it, nothing else. And probably like once done, when it is open for the chat, it will be chat, right? So means to say, of course, are we marketing? Yes, we are marketing by adding value, right? That's as simple as that. Yes, coming back. So means to say, doing all these things for this project is what is being covered in this. Okay. So let me like straight away sell, or probably like means to say how you take it, the way you take it, like you can take it. So uh, this is real time projects. This is the real time projects. So this course, of course, like I'm not really going to give you any uh, discount or something. This is like I mean to say, I can add probably additional value. If you want to learn, you can probably straight away pick up this course, 5,000 rupees. But one bonus which I can give you, I am handling the class 5:30 a.m. on Thursday and Sunday. Every Thursday and Sunday, India time 5:30 a.m. to probably solve this step by step in a real time. And I will ensure that like you will be completing the slow flow for the study. That's what I'm trying, which is already going on. So, like me to say, whether you can pick it up this course, choice is yours. But those who are picking up this entire ETAP course, so it means this is only for a load flow. Like this is only for a load flow. This is only for a load flow. You can pick it up. It's a pre-recorded. It's a practical real-time case study. 5 hours of recording sessions, and probably like till December, like every Thursday and Sunday, you will have like means to say live sessions with me personally, 5:30 a.m. 5:30 a.m. in the morning India time. So means what to say that's probably like kind of a real-time case study. But if you want to learn this complete power system studies, like I'm not really going to share the link. You can probably like means to say get it from our team. But if you want to learn the complete power system studies using ETAP from us, uh, maybe Manoj or someone, can we put like the brooch in the chat so that like audience knows what we are doing? So we cover like all power system studies like ETAP with the load flow analysis, short circuit studies, motor acceleration, transient stability, relay coordination, harmonics, arc flash, like all the 7 studies. So when my team is probably putting like I mean so say putting a message